Okay, so if I want to, this problem is asking me about work done by a field and change in potential energy and the velocity. So let's start by, I like to think about an electric field and what it might possibly be created by. So I like to think about a positive charge would create an electric field to the right and then in the positive x direction here. So that I can think about this arrangement to create my positive or my electric field. So if I have an electron right here, it's asking me after the electron has moved 3.2 centimeters, what is the work done by the field on the electron? So I know that this electron is going to be pulled towards the charge. It's going to be move against the electric field. So I know the equation for work is Q times E and times Y2. Well, it's Y2 minus. Let me just erase that. And it's going to be X2 minus X1. Okay, so work equals, and Q for an electric field, or for an electron, is 1.6 times 10 to the minus 19 coulombs. My E is going to be 375 newtons per coulomb times, and this X2, if I think about X1 would be here, and this is going to be X1, and when it moves this way, this is going to be X2. So if I say X2 minus X1, I'm going to have a negative 0.032 meters. And if I think about my charge here, my charge is going to be negative. So when I solve for this equation, I'm going to get a positive, and when I plug in the numbers, I get 1.2 or 1.92 times 10 to the minus 18. And then the units are coulombs. Let me just move this down a little bit. So I have coulombs times newtons per coulomb times meters. So I have my coulombs cancel and I'm left with newton meter, and a newton meter is a joule. So I'm going to have 1.92 times 10 to the minus 18 joules. So that's part A. Now B, it says, let's go back. It says, what is the change in potential energy associated with the electron? And this is after the electron has moved. So when I think about potential energy, the potential energy when the electron, so if this is my positive, that's my positive charge that's creating this field, and I have an electron out here, when I'm here, out far away, I have a higher potential energy than when I'm here. My potential energy is lower. So the change in potential energy is the same as the work done by the field. So that's going to, because their potential energy and work are both units of energy, then the change in my potential energy, so PE, is going to be a negative 1.92 times 10 to the minus 18 joules. So that's what you want to think about is the closer or the farther away this electron is from the positive charge, the more potential energy it has. Meaning, if I think about energy, energy would be if I were holding this electron and then I were to let it go, it would move towards the positive charge. So because it would move, it's going to be pulled towards it, and so therefore it's going to have potential energy. And when it gets here, the potential energy is going to be lower. So it's losing potential energy when it goes from here to here, thus the negative. And then it's asking about the velocity. So I have so if it starts from rest here and it goes to here and it uses this much energy, then I can say its kinetic energy is equal to its change in potential energy. And so that's equal to 1/2 mv squared. And I'm going to say m sub e for mass of the electron and v squared. So now I can solve. So V is equal to the potential energy times 2 divided by the mass of the electron, and this is all square root. And when I plug these numbers in, I get that answer of 2.05 times 10 to the minus, or times 10 to the 6th. And that's because this is going to be 1.92 times 10 to the minus 18 joules times 2 divided by the mass of my electron is 9.1. Let's see, I looked this up. Oops, not that. There we go. There we go. So the mass of an electron is 9.10938. So 9.10938 times 10, times 10 to the minus 31 kilograms. And so when I multiply that through, I find 2.05 times 10 to the 6th meters per second.